All right, guys, here we go. Normal distributions, example 4, part C. We were told that life expectancies in the United States are normally distributed with a mean of 78 years and a standard deviation of 7.2 years. And we want to know what's the probability a randomly selected person will live to be between 86, which is above the mean, and 94, which is also above the mean. Between. So that visually would be the area we're looking for. Probabilities relate to areas when it comes to the bell curve. And so again, we'll put the 86, which is less than X, which in turn is less than 94. It's important to label the fact that the variable at this time is X. It's just a random variable, in this case representing age, life expectancy of a person. So once again, we need to, in order for us to be able to use our beautiful table, we're going to need to standardize that score, make it into a Z bell curve, 0 in the middle. And again, both of these ages are above the mean, so they hopefully will translate into positive Z-scores when we change them over, when we standardize them. So, in order to prepare this for the table, we change the variable from X to Z. And this, to me, is our little translator. It'll take a value of X and find out its Z-score. It'll standardize it in the language of statistics. So, applying that to 86 years old, we would take 86 years old minus the mean of 78 and divide that by the standard deviation of 7.2. And that particular one, make sure when after you subtract this, you equal it out, then divide by the 7.2. And that comes out to be 1.11. So that age is 1.11 standard deviations above the mean. Notice again it came out to be positive, which is what should happen. So 1.11 would be the value for that one. All right, then we do the same thing for the age of 94. 94 minus 78 divided by 7.2. And again, we round these to 2 decimal places because the table that we are using takes Z-scores out to 2 decimal places. And that one comes out to be 2.22. 2.22. Where have I heard that before? Are you sure that that was 2.22? Let's try that again. I don't know if you can hear that very well. The volume's not very good on this thing. 2.22? 222. All right. So anyway, we've got that. And, again, once it's been standardized, then here we go. We're ready to use our beautiful table, aren't we? Table time. I can hear y'all. Awesome. Thank you for joining in on that. All right, so anyway, if we look up the 2.22, that gives us a middle region of 0.4868, 0.4868, and that would be this region right here, 0.4868. That's from here to the middle. This table always gives you that middle sliver. And then likewise 1.11, 1.1, these rows here get you out to 1 decimal, the columns get you the 2nd decimal. So the intersection of 1.1 and 0.1 is 3665, 0.3665, 0.3665. And as we practice multiple times on assignment 16, I'm hopeful that you would realize from that picture that in order to get that shaded region, we'd want to take this and subtract this. So we'll do that over here to get our final answer. 0.4868 minus 0.3665. I hope my math is good. 0.1203. That looks right. All right. Again, optional. The question did say probability, so I wouldn't have a cow if you left it decimal. But if you want to change it to percentage, you wouldn't. You can do that. I wouldn't have a cow because basically I'm not a cow and I'm a man. But anyway, enough of that, and that would be example 4, part, what was it, C, I think. All right.